Right, hello everyone. In this video, I'm going to talk about the reason why we divided by k when we dilate from the y-axis, right? In this case, the k is a dilation factor, okay? So let me show you what that looks like graphically. So we have x and y-axis, for example, that's the x, that's the y. Now let's say we've got a point here, that's the x. And okay, let's say this point, and this point is going to be y, okay? And let's call this point the original, or the old point is going to be x comma y. And when we dilate this, we'll move horizontally, and then let this would be the new point, and this new point is going to be kx comma y. We call them, we're gonna call this the new x, which is represented by dashes at the top, and the new y's, okay? Those two are the same thing. Now, from the graph, you can see that therefore we know that x dash is equals to kx and y dash equals to y. And the goal is we want to write the old x and y in terms of the new x's, the new variables. If that's our main goal in here, in order to show that there's a division by k when we dilate from the y-axis, okay? So what that means is, now if I solve this for x, I'm gonna get x is equals to x would equals to x dash divided by k. And if we do that for y, well, in this case it doesn't really change. Y would equal to, should have used the same color, well, it doesn't matter now, y dash, right? They're the same. Okay, so that there you see there's a division happening here. So then the old x is equal to the new x divided by k, whereas the old y is equal to the new y when dilated from the y-axis by a factor of k. All right, so let me show you these in terms of a matrix kind of notation. So we know that x dash, so these would be in matrix notation. So let's say matrix notation. All right, so that would be x dash would equals to t times x. We know that t would be equals to k 0, 0, 1 times it by x is going to be the same as xy. And if we expand this, we'll get k times x plus 0 times y. And on the bottom, we're going to 0 times x plus y. 1 times y is going to be y. So we get kx over y, as we would hope so, because this is the new x, that's a new y, that's a new x, that's a new y, that's what we get there. So they both agree in terms of the solution we're getting there. So we can write x dash is the same as the big x, this big dash is the same as this one, which is little x dash little y dash equals to this value, which is kx and y. And we want to solve oh, what have I done now? We want to solve the the variables. Okay, sorry about that. The variable, the old x and the old y in terms of the new axis. So what that means is we can say that this follows that x dash is equals to kx and y dash is equals to y. And if we solve this for x, we're gonna get x is equals to x dash over k, y is equals to y dash. So again, we reach the same conclusion as we did here in the previous case. This is using the general rules. This is using matrix rule. And now, the alternative way to do this is to use our knowledge of the matrix, right? So what we're gonna do is the following. Let's do something here. Oops. I zoom in a lot. That's not good. So what I'm gonna do is I'm gonna write the old matrix. So let's write. Since we're solving for the x and y, I'll put this way. I'm gonna say the new x is equals to tx, and we'll just solve for the old x. So using matrix multiplication, right? So that would be if I multiply both sides by pre-multiply both sides by t dashes, right? So this is what I mean. Let's put these into brackets. Put into brackets. And nothing changes. So if I pre-multiply by the inverse of t by the inverse of t, well, we know that from matrix algebra, t dash times t would give me I, the identity matrix, times x. And that's give me t dash times, oh, not t dash, t inverse times x dash. Well, we know that I times x is going to be I. Sorry, not x. So we got t inverse x dash is going to be x. Let it move over here. What that means is then x is equals to t inverse of x dash. Okay, let's find what that t inverse is. We could get t inverse is going to be what, and what is t dash? Okay, so t inverse, so remember t is this. So let's just write it down so that we can reference them back. T is equals to K001. So T inverse would then be equals to, we're going to switch these two, and we're going to get the negative of these two. This and this will be negated, right? And then we also need to find the determinant, right? So t dash would be, we're gonna switch, so 1 over t determinant time we're gonna switch, so we're gonna get k1. Well, if we negate what's a negative of 0, negative of 0, negative of 0, well, that still would just be 0. What is t determinant would be k times 1 minus 0 times 0. That will just give us k. So t inverse would be 1 over k. That's from, the determinant is k, so 1 over k there. And then we're gonna get Oh, I haven't switched them, have I? No, I didn't switch them. I should have switched them. These two are going to switch their position. This should be 1 and this should be k. So these two, they will switch their position as I said it earlier. And now we'll get the following. I'm gonna get 1 0 0 k. X dash is gonna be new x dash, new y dash. That gives us, well, let's just multiply these two, these and that. So we're gonna get 1 times x dash plus 0 times y dash, 0 times x dash plus k times y dash, and we get 1 over k at the front. We're gonna get x dash over k y dash. Now if I distribute the k in, I will get the final solution, x dash divided by k, and then we're just gonna get k dash because these k and that k will get cancelled off, and that is equals to, I should write down the x's, shouldn't I? X, that is xy. So as we can see, we get x equals to x dash over k, y dash over k, and we also get that same solution over there. And oopsie, should have done that. And we also get the same result here, there. All right, this is using like a straight matrix notation. And the last one is by using the inverse matrix approach to get the result that we wanted, right? So there you go. Those are the 3 ways of doing it. And I hope you enjoy the videos. Right. Thank you.